Alright, hi class. Here's a video on mining. I'm continuing on from class on Friday where we talked about the rock cycle and basically how we have different minerals in our Earth's crust, of course, and ores are a concentration of these minerals in a rock that is profitable to mine. So, mining's been done for many hundred years, and these are just some techniques that have been used. So I'm going to start off first talking about the mining law of 1872, which was a really important law in the United States because it allowed individuals and companies to recover minerals or fossil fuels from federal lands. And this was passed to encourage the development of the western United States. What's really interesting about this law, though, is that it still does stand, and it contains very few environmental protections. So, under this law, you can go as a company and mine and dig up the land. And at that point, there were no laws to clean up essentially what you did and try to restore the land back to how it was, or at least somewhere close. So the consequences of this law, of course, we got some settlements and developed areas in the western United States, which is good for us Californians, but we also have some negative consequences, and one of them is that you can still buy public lands at 1872 prices if you use it for mining, and that's pretty darn cheap. It's $5 an acre. So a company can go buy public land if they're going to use it for mining for basically nothing. And so whereas before it was used to encourage the settlement of the United States, now it's encouraging, the destruction of many of our public lands. So that's problematic. And there have been many kind of efforts to change that. And we'll talk about the laws that were passed to help kind of clean up the act, so to speak. But here's a diagram. Basically, I like it because it shows, all the different types of mining. So here you have the different types of surface mining, mountaintop removal, and the strip, and the open and placer mining. And then here you have the subsurface mine, or the underground mining. So I'll go into each one of those. So for the surface mining, the first one is the strip mining, where you basically remove the soil in these strips to expose the ore below. Okay, and this is done for certain types of minerals or coal, for instance, that is deposited in what are called seams. And coal is deposited in a seam, and we'll talk, when we talk about coal, this will make a little bit more sense, but it's basically this compressed plant material, the semi-decomposed plant matter, that basically formed an entire layer. So a strip mine would be done when you do have a predictable abundance and location, and pretty reliable kind of strip of some sort of mineral. It's pretty rare. Coal is a good example, though, because you can just go in and it's all kind of just laid out there for you, and you can really efficiently go through and just dig these parallel trenches. And here you have what's basically another diagram showing overburden removal, and I just mentioned this because in mining terms, overburden is essentially soil and rock and anything else that is needed, is basically the earth above the ore. But they call it overburden because it prevents them from getting to the ore. They want to remove that, but, we're going to be talking about soil in class when I see you next, and, this is very valuable land and soil for the productivity of that land and for growing plants. So one person calls it overburden, another person calls it soil, and kind of all, what we need to grow, what sustains us on Earth. So different terms for, different purposes. And then open pit mining is basically a large pit. And this is done when minerals are scattered more throughout the crust, and it's not kind of in these nice seams like the coal is. And you essentially just have to dig a big hole, and they do have equipment to find it in a more predictable fashion, but essentially you have a humongous hole. And I'll show you a video where you can see just how large some of these can be. And then you have mountaintop removal, which is pretty much what it sounds like. You remove the top of an entire mountain, and you can do this with explosives. You may have seen mountains that kind of look stunted at the top, and most likely it was because of mountaintop removal mining. And It's an easy way to get under the mountain without having to do much work if you can just basically explode the top of it off, but you can imagine the devastation that it causes below. And then the last one is this placer mining, and we're probably pretty familiar with this in California when we've learned about panning for gold in the different riverbeds around our state. You can also have these kind of sieves and filters where you're able to pass water through and the sediment goes. You can think of the negative consequences in the river with all the sediment and disruption of the riverbed. So that's placer mining. And then we have subsurface mining. So there are two types, and these are done for resources that are below 100 meters under the Earth's surface. And we have a shaft mine, which is the deepest type, and you can see that here. It's basically an elevator going down. And then the slope mine, which is a slanted passageway, and you can see that here. So obviously that would be for something that's shallower. Okay, so a little bit closer look at the shaft mine. Again, it's the deepest type. It can be a half a mile deep, and this is, it's important to fill it up once it's done so you don't have a huge hole. But you can look at this diagram. It's kind of neat, and you see the whole ore here. And in order to get to it, you have to basically dig down and create basically an underground elevator. And then you have these passageways that go to the ore itself. And you can see how they're slanted so that when you take them back, you can kind of use gravity to help you drag them along. But then you have to use these elevators to bring them back up to the surface of the earth, which is very expensive and time-consuming. And then you can also see there's a ventilation shaft to get air down. And then the slope mine is, again, the slanted passage, and it's a little bit easier to get the minerals out because you don't have to use the elevator. You can use some sort of conveyor belt to pull the mine cars out. You don't have to use kind of the buckets or an elevator, which is more time-consuming and dangerous. Okay, so those are the different types of mining. Now for the environmental impacts, which of course there are many. Probably the most obvious is that it just disturbs the area quite a bit. You dig up all the soil, you make it prone to erosion so it can wash into waterways. You are of course destroying a lot of habitat. If you had a forest, which it looks like this one was, you're cutting down all the trees and you don't have a forest anymore. Even if you don't have a forest, you're digging up the land, making it hard and impossible in many cases for plants to grow. And any of the animals that have been living underground or burrowing there can't do that anymore. So that's very disruptive. Also air pollution. So there's a lot of dust and emissions. The dust from the land itself, and then emissions that are released from the mining equipment. And the mining equipment, is not very energy efficient, so it does release a lot of emissions. And then something called acid mine drainage, and this is a pretty nasty thing, and it basically is this pollution that's caused when all of the metals, and so when you're mining for, let's say, gold or copper, even if you're not looking for sulfur or lead or all these other toxic minerals, they're still going to wash out into the waterway nearby and basically be pulled, they're exposed from the mountain, the side of the mountain, and so they're going to wash away. So these are the unintended consequences because you weren't looking for these, but they're there anyway, and they're going to wash out and just kind of flow into the nearest waterway, and you get streams that look like this because all of these metals are just sitting in our Earth's crust, and they would just stay there, but once you start digging away, they flow out, and once they get into our water, that's really problematic because we of course drink water, and you don't want it to be toxic. And we'll talk about that when we get to water pollution. So just kind of a summary of the different environmental impacts and the different types of mining. You can look at surface mining and see, the effects on soil, which are of course huge, and habitat alteration, water. And then subsurface mining is more minimal because of course you're not digging up the entire land surface, you're going underground. But the trade-offs, there are always trade-offs, and surface mining, although it's more damaging to the environment, it's less threatening to humans. It's more hazardous, of course, to go underground. And that is why surface mining is more common than subsurface mining now, because we have the huge equipment, and it's less of a risk to human health and our lives. But it's a trade-off because this is also important for our lives. So clean water, clean and productive soil. So it's important that we also take measures to kind of make this as a minimal impact on the environment too. And so we have, and some of the restoration of mining lands is being done, and although you can't restore a habitat completely back, you can prevent further degradation and erosion. You can try to eliminate some of the sources of these toxins and try to make this land productive for another purpose. So there was an act that was passed in 1997, over 100 years after that first mining law. So think for 100 years, mining was done without this kind of measure to require the filling of these mines. So these surface mines now have to be filled back. This is very expensive. But before this, you could just go and mine and just leave it. So it's important that we have this act in place. It's also going to help to reduce acid mine drainage, because if you fill it back up, those metals aren't going to be exposed anymore that can then go into the waterway. You have to have permits and inspections of active mining sites, and you also need to you can't mine in sensitive areas, although how these areas are defined is very questionable. And what does a sensitive area mean? A lot of people can debate and argue and have different ideas about that. So again, this is the law, but enforcement is certainly a problem. And so this, this is something that we have to do a better job with. And you might have remembered, remember some of the mines, coal mines that some folks died in, and they, they had an active mine going, but they didn't enforce any of the inspections, and, people died and there were explosions and things. So this is the law, but again, the enforcement is a big problem. And just in terms of the restoration process, so we have traditional steps. So here you can see an area that was a mine and was dug for minerals, but you can restore it to an area that looks like this. So the first step is to fill in the land, and then you kind of grade it, reshape it so it looks natural, and then you can plant vegetation to hold the soil in place and to hopefully regrow some sort of landscape there. And you can see another picture here. They're kind of doing the natural contours, and you can compare these different areas 10 years later, or sorry, 5 years later, and then these are 6 years later. It definitely looks better. By no means are you going to get this nice forest back, very soon, and the animals to come back. Again, succession is a natural process, and this speeds it up. But there's certainly a lot of habitat destruction, but it's certainly better than nothing. And wetlands, lastly, are another really great restoration method. And wetlands, if you remember when we talked about biomes, they're essentially like sponges. They are usually at the kind of the boundary, the border of a landmass and a waterway like an estuary. And as the water goes from the land into an estuary or a bay or the ocean, they trap a lot of the sediment and pollutants before they get into the streams. There are a lot of bacteria that live in the wetlands, a lot of microorganisms that break down the toxins that are traveling from the land into the water, and they can neutralize acids. So they're essentially, again, like sponges that are going to help detoxify whatever is coming through. So, and then in that way they would improve the water quality downstream. They're very expensive to create, but you can create them. This area here, this parking lot, if you remove all the concrete, bring some, either bring some soil in or reshape it and recontour it so you have a low point. And if it's wet naturally, it'll form back into wetland. You might have to reseed it. But it's pretty impressive what we're able to do in terms of our restoration techniques. And of course, it is expensive, but down the road it's cost effective, depending on what the problem was here. If there was a lot of pollution, a lot of toxins, a wetland will be a natural detoxification system for you, and you won't have to actually do manual cleanup, which does happen in some areas. Okay, that's it. In class, we're going to start talking about soil, which of course is above all these minerals that we mine for. All right, thanks. Have a great weekend.